In this video, I'll be showing you how to design a beam raft foundation using the software ProtaStructure for our 3-story residential building. In this design, we are faced with two major challenges, which is one, that this 3-story residential building will be sitting on a very weak soil. The next challenge we are facing is that this 3-story residential building is transmitting a very high load to the soil. So in this condition, normal part footing base won't work because it won't be able to distribute the load coming from this structure evenly to the soil, which risks settlement and structural failure. That's why for this structure we are using beam raft foundation, a robust continuous base that ties all columns together and spread the load uniformly, which then distributes it to the soil. In this video, you will see how to model a beam raft foundation in ProtaStructure. You will also see how to analyze and design a beam raft foundation, and most importantly, I will be exposing the governing principle governing beam raft foundation and how it transmits its load to the soil without failure. By the end of this video, you will know exactly when, why, and how to design a beam raft foundation for any challenging soil condition. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering, and in this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe.
In our last video, we were able to analyze and design this 3-story residential building. Yes, don't forget, we started from the general arrangement drawing, then we entered ProtaStructure and we did our modeling, and then in our last video, we did the analysis and design of this structure. And in this video, we are going to be doing the foundation design, and we'll be using beam raft foundation. Yes, in this structure. Reason why we chose the beam raft foundation is because the soil bearing capacity we got from the soil report is 70 kilonewton per meter square. So the soil is very weak. Yeah, the soil is a very weak soil. That means the load will not be distributed evenly if we use part foundation. So for that reason, we'll be using beam raft foundation. So in beam raft foundation, let me turn on my layers. I'll turn on my layers. I'll turn on my axis, turn on my ghost axis, turn on my print definition, and also turn on my test. So right now I've turned on everything. So I'll be going to plan view. We want to carry out our foundation design. That's the beam raft foundation. Then I'll come over to story 0. Yeah, because we are talking about foundation. So I'll come over to story 0. So if you can see, I'm not seeing the beam line we did in AutoCAD doing our original element drawing. Yeah, I'm not seeing it in this foundation plan. So to see it, I'll come to this external reference drawing. That's under building setup. I'll come to external reference drawing. I'll click on it. Yes, and then come to this story number. I'll select story 0. Yes, and then click on OK. So right now I've seen this thing. Reason why I brought this thing to this story 0 is so that I'll be able to model my beam. Yes, because you know beam raft foundation is all about beam. Yeah, so I'll be able to model my beam. So I'll come over to modeling and then click my beam tab. Yes, so look at this. I'll click my beam tab, foundation beam. So yes, that's what I want to model. I'll click on OK. So right now we'll be using the column, we'll be using the beam size of 225. Yes, we want it to still be the same column size that we have. So beam size of 225 by 225. Then, but the depth of our beam now will not change. If the depth of your beam is less than 1 meter, if it is less than 1 meter, that means, so if it is more than 1 meter, that means it will be designed as a shear wall. But if it is less than 1 meter, that means what you are designing is not really a beam raft foundation. It is called wide strip foundation. Yeah. But if it is above 1 meter, that means you are designing for a beam raft foundation. So the depth I'll be using in this building is 1 meter. But if it fails, I'll come back and increase it. Yes, if it fails, I'll then come back and increase it. Maybe I'll not go for 1,200 millimeter or so or thereabout. But for now, I'll be using the depth of beam to be 1 meter. Remember, this is foundation beam. This is not just a normal beam. This is just our foundation beam. I chose 1 meter so that the load will be transmitted to the soil evenly. Yeah, so with this now, I've chosen everything. So I'll just come and model my foundation beam. Yes, I'll just follow this beam line that we did in ProtaStructure. Just model my foundation beam. Yes. So if you see it is white in color. Yes, the reason why it's white in color is because this beam now I've not yet designed it. Let's go to 3D view. So let's go to where we have designed. Look, if you can see, it is white in color. Reason is because I've not yet designed this foundation beam. Yeah, but in which I would like to turn off this design status. I would like to turn it off. then click on it, then click on, I'll come to none. I'll click on none and then click on OK. So after I'm through with the design and everything, I'll then turn it on again. So I'll go back to my plan view. Once I come over to my plan view, I'll also like turn it off here. So I'll turn off my design status off here. I'll click on this, then click on OK. Then I'll come back and double click on this. Sorry, and double click on this to pick its property. Yes, I'll double click on it. Then I'm having this from this point to this point. Yes, I'll escape and then I'll do for I'm having, okay, let me come to this side. I'm having from this point to this point. Yes, I'm also having, sorry, I'll double click on this again. I made a mistake. Then I'll move from this point to this point. So right now I want to just trace all our beam. Remember, if you do not follow this video from the general arrangement drawing, I will advise you to go and watch the general arrangement drawing, so you get to learn a lot. So because in that general arrangement drawing, we were able to explain a lot of things. Yes, both the governing principles in column placement, in beam placement, and even in paneling. So if you watch it, I bet you will really learn a lot. Yeah, you will really learn a lot. So sorry, I made a mistake. I'll double click on this. So, and also try and get the cat file and practice on your own. Yes, because practice makes one perfect. The more you practice, the more you get to learn. So try and get the cat file and then practice on your own, so you know it very well. So remember, if you practice, if you just watch 100 videos without practicing any, and someone watches only 10 videos and practice only that 10 videos that he watches, I bet you that person will be far better than you. Yeah, that person will be far better than you. So right now, what I'll do is that I'll pause this video and just input all my beam. Once I'm through, I'll then resume back. Right now, I'm through inputting all my beams. Yes, I'm through with all my beams. So what I'll be doing next is to input my slab. So I'll come over to modeling. Yes, I'll come over to modeling, then double click on my slab. So I click on my slab. So what I will be having as my slab is I will be using the slab depth of 200. Yes, because this is a foundation. This is a foundation slab, not a normal slab. So I'm using the slab depth of 200. I'll still leave the concrete cover at 35. Yes, I'll leave the concrete cover at 35. That's the bottom, but the top I might use it. I will now doing the then I'll use the top concrete cover to the 25. Then coming over to my loading, the same dead load, I'll be using 1.5 based on what I've explained earlier. That is partition load and finishing load. Partition load being 0.5 and finishing load being being 1. Then coming over to my impose load, I right click, then click on general domestic use. So this is what I'm having right now. Then I'll come over and start inputting my slab. Yes. But let's check something. Let's come over to our 3D view. Let's check. So if you look now, look at what you are seeing. This slab is being placed at the bottom, but we are not supposed to have this slab at the bottom. We are supposed to have it at the top. So to bring it up to the top, what I'll do, let's come over to plan view. Let's come over to plan view. So I'll double click on this beam, this slab again. Then come to this relative level. Relative level. I'll do 1000, which is the depth of my beam minus the depth of my slab. So 1000 minus, that's 1000 minus 200. I'll be having 800. So I'll then click on update. Once I click on update, let's go back to our 3D view. So if you see now, look at our 3D view. Look at it now. It's not up. It has gone up. Look at it. I've been seeing it. So this is how it should be. So I'll come over to this my plan view again. Then double click on it to pick its property. Remember, I'll place it here, I'll place it here, place it here, place it here, place it here, and also place it here, and also place it here, place it here, and I'll also place it here and place it here, and I'll still come and then place it here, place it here, and I'll place it here and place it here. The one I place here did not appear. Then I will come and okay, I'll place it here again. Then for this one, I would like to use a beam and divide here. So let me escape. I'll double click on this. I'll double click on this. I would like to divide this into two. You know, these are staircase region. So here was void in our story 1, story 2 to story 4. It is a void. But in this case, this is a foundation beam. It's not a void. Yeah, so I would like to use that beam and demarcate it. So let's see what we have done in our 3D view. So looking at from our 3D view, this is what we have done so far. This is what we have been able to accomplish. Yeah, so the next thing right now is to design our slab. That's to input our slab strip. So that I'll come over to story 0. Then we have to input our slab strip. So once it comes to superstructure, that's from story 1, story 2, story 3. How it is being done is that after your design, then you now come and design your slab separate. Yes, after your design, after your analysis and design, now come and design your slab separate. But once it comes to foundation, the way it is done is that before you design anything, you first of all draw your slab script. Yes, because during the design, during the analysis and design of this foundation, the slab, it will also design and provide the reinforcement for the slab. So before you do your design, make sure you input your slab script. So for that, I'll come over to modeling, click on this slab script. So this dialog box will appear. Remember, in our superstructure, we use analytical model, but this is foundation, and two, this is a beam raft foundation. So we are using finite elements. Yes, we are using finite elements. So I'll come over. This is my x direction. So what's the boundary condition? So we'll be doing from this point down to this point. So the boundary condition will be this, which stands for void, beam, and slab. Look at it. The end is void, then we're having beam, and then we're having slab, and this is also the end boundary condition. So I'll come over to this point, do my then I'll hold my control key and press it here. So if you see, I've placed my slab strip at this point. Then next one I'll do now is from this point to this point. Yes, I'll click here from this point. I'll hold my control key. I'll hold my control key to this point. Then next one is just from here to here. Then I'll hold my control key. I'll hold my control key. I hope I got it well. No, let me escape. I not get it well. So I'll come ahead, I'll press it here. Then hold my control key to straighten the line and press it at this point. Then if you see, we after all this the slab that we did, it not cut across this slab. Yes, I it not also cut across this slab. So for that reason, we'll come and run the slab strip for this slab separately. So if you see, it is surrounded by slab. So the boundary condition will be this and this. So I'll do from this point to hold my control key to straighten it to this point. Yeah, so it will design for this slab. Then I'll also come over to this point and hold my control key from here to here. So look at it. Then after this, the next thing is to do for the vertical direction, that is the y direction. I'll come over to this and click on my y direction. So what is the boundary condition? I'll still pick these two things as my boundary condition. Then I'm having the slab to run from, I'll hold my control key to run from here. Let me hold my, okay, let's wait for it. It will run from here. I'll then hold my control key to straighten the line. I'll click on this point. So coming over to this point now, we're having here. Remember, we have designed for this slab, so we will stop here. So that means this is our starting boundary condition, and this will be the ending, the boundary condition, the end boundary condition, because we're having slab, beam, and slab. Yeah, so this will be the ending back condition. So I'll pick this point, then hold my control key to strengthen the line, then click here. So I'll come over and decide and set this is now my new boundary condition for this one. Now I'll move from this point, hold my control key to this point, and for this one too, I'll also from here to hold my control key, and for this too, from here I'll hold my control key. Then for this one now, the boundary condition will be this, because it will be okay. Don't worry, let me just do for this one. I'll click from here and then hold my control key, yes. Then once it comes to this side, since you have designed for here, I'll now do from the extreme. I'll pick this extreme part, yeah, so it will design for only this slab. So this is what I'm having. I'll click on this. So if you see now, I've successfully run my slab sleeve across this whole slab. Okay, there's something I want to explain here. Let me remove this. There's something I want to explain here. For example, let me explain using this column. Once you come over to this column now, let me say this column is carrying a very high load. So at this point, this column will spread its load around this slab. Yeah, it will spread its load around this slab. That means this slab now will not help to distribute the load coming from this column to the soil evenly. Do you understand? This column now will spread its load around this slab, and this slab will now help to distribute its soil, to distribute its load evenly to the soil. But coming over to this perimeter columns, that's this column at the edge. Yeah, if you see this column now, it will only spread its load around this slab. Yes, it will only spread this column around here. There is no slab around this area for it to spread its load to, like for it to distribute its load to, so that slab will not distribute it to the soil. That means in our design, there is high probability that we'll be having failure around this edge, around this edge, in fact around the perimeter columns, this column, around this column, around this column, around this column. Reason is because the load coming to this column is not being spread to the soil evenly. Yeah, the load is somehow concentrated at this point. That means it will cause something like punch on the soil, and causing that punch on the soil causing that punch on the soil, it will result to failure. But for this column now, if you see, the load will be spread around this slab, then this slab will now distribute it evenly to the soil. While here now, the load is not being spread, the load will be spread around here, while this side is still void. There is no slab that will help in spreading this column load to the soil. So for that reason, we'll be introducing a cantilever slab around the edges of this beam raft foundation, around the whole edge. We will be introducing a cantilever slab so that it will help and spread the load coming to this structure evenly to the soil. If you do not introduce this slab, I bet you most of the time most of the time it will fail. Yes, it will fail. Or if you don't want to introduce the slab, you can go and introduce a very high beam depth, but I'll advise you just introduce a slab. Yeah, so but we'll be going with the minimum cantilever length of 500. Then if it fails, we'll then come back and then increase it again. We'll be going with minimum cantilever length of 500. So I hope you understood what I explained, the reason for introducing this slab, to help and spread the load coming from this column. Yeah, because if the load is not being spread, that means the load will be concentrated at this point. And if the load is concentrated at this point, it will cause punching on the soil. And once it causes punching on that soil, it will fail. So to help spread the load, we are introducing a cantilever slab. So I'll come over to this slab, click on my slab, then the slab depth that I would like to use is still 200. Yes, the still 200. Then I'll come over to this point. Okay, the concrete cover, I'll still like to use a concrete cover of 35. Then coming over to this point, I'll pick cantilever length of what? 12. Then I'll leave the load. I will not apply anything on the load because the only load that will be applied here is the soil load. Or I can just choose to apply the soil load because it's only soil that will be resting on it. That's the soil load. I can just choose to apply the soil load to be 0.5. Yes, I can just choose to apply the soil load to be 0.5. Then I'll not apply any other load again. Then I'll come over to this cantilever length. I want to choose the minimum to be 500. Then once it fails, I'll then come back and increase this length. So I'll start from this point. I'll move from this point to this point and then extend it out. I'll move from this point. Hope you understood what I explained for this point and then extend it out. Move from this point to this point and then extend it out. Yes, and then I'll also move from this point to this point and extend it out. Reason is so that the load coming to this column will be spread evenly. Yes, it will be spread evenly. Hey, sorry, I made a mistake. I'll cancel. Remember, assuming I not include this cantilever slab now. Okay, let me just do this. Assuming what's going on? Okay, look at it. Assuming I not at this point, now what will happen is that at this point, this column will not spread its load to this slab and also to this slab. Then this slab and this slab will not help and spread its load to the soil evenly without causing much failure. So that's the reason for introducing this cantilever. Then I'll introduce it here. Yes, this is what I'm having. I'll move from this point to this point. I'll bring it down. Yes, this is what I'm having. I'll move from this point to this point. I'll bring it down. So right now I'll pause this video and do everything so I'll not waste time. Remember, you can get the CAD file and practice on your own. Yeah, so it's not just about watching this video. If you practice it, like, it will become part of you and you get to know it more. Yeah, it will become part of you and you get to know it more. But I'll be pausing this video right now.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
So right now we have two inputting our cantilever slab. So if you can see, this is what we are having right now. But let's go over to our 3D view and see what we have done so far. So this is our 3D view. Let me turn off my axis. Yeah, let me turn off my axis so you see it clearly. So I'll turn it off, turn off this, and also turn this off. So this is what we are having right now. So if you can see, we have successfully modeled this beam raft foundation. Yes, so the next stage now is to go to our setting. Yeah, go to our setting, input our soil bearing capacity, not just that, and also do some other settings once it comes to foundation. So right now, let me turn on everything. So I'll click on display, click on layer, I'll turn on my axis, I'll turn on my ghost axis, my plane definition, and my desk. So everything has been turned on. So next thing now to do is to come over to my settings and do some settings. So I'll come over to my settings, then come over to foundation. So this is my foundation. Yes, and input my soil bearing capacity. Remember, we said that the soil bearing capacity we have here is what, 70 kilonewton per meter square. The soil unit weight is, you just leave it like this. This is the soil unit weight. And also coming over this subgrade coefficient, you leave it like this. If you want to change it, that means you have to go over and change it. That's if you know about the subgrade coefficient well, or you can read it up in Joseph Boyce. Yeah, you can read it up there, so you get more knowledge on it and change it. But I'll advise you to leave it at this, because this is just the general value that we use. So I'll click on cancel. Then the lane concrete thickness. The lane concrete thickness is just like the branding. Yeah, the branding. That's a weak concrete that will first of all lay. You know what is branding? Brand is just a very weak concrete. We are just trying to avoid letting our beam or our beam lab foundation have direct contact with the soil. So for that reason, we will lay our branding. So they're asking of what is the lane concrete thickness. So I would like to use 50. I don't want to use 100. And what is the lane concrete extension? That's if you are extending it, just make it as 50. Yeah, I would also like to use 50. So this is about split footing and this is about part foundation. So I'll still leave this at default. And most of the things here are about part based foundation. So I'll still leave them at default. And then coming over to my steel bar 16, so I'm okay with it. That's for my beam. I'm also okay with this. So I'll come over to this point and then click on okay. Yeah, so click on okay. So once I'm through with this, next thing to do is to carry out my analysis and design. So I'll come over to this point of analysis. I'll click on FE foundation analysis. I'll click on it. Once I click on it, this dialog box appears. So I will check this to use the subgrade reaction value assigned to slab for soil stress check. So I'll check this. I'll also check this. That's to include column section in FE model. I also check this to consider beam torsional stiffness, and I also check this to release column top node in S and Y direction for FE foundation model. So I'll check these three things. Then this one, apply load reduction. Remember, when we are editing our story, I talked about load reduction. Load reduction is normally used in high-rise buildings. Yes, they are normally used in high-rise building because not all the soil will be in use at all times. So that is when we do apply load reduction. But I will not use this. This one say display analytical model before analysis. Me, I will not like to check this. You just once you start analysis, before they will analyze, they will not display for analytical model. I don't want this. I want to be fast. Then this one, use space solver for analysis. Don't check this. I will not also check this. Don't also check this. Then this one, refresh the connectivity information of all beam member. I'll just leave this at I'll just leave this. Then coming over to this one is the shear element size. So this thing now, the lesser it is, the better. Yes, the lesser it is, the better. Because I'll still show you what this shear element size means. But if you are the lesser it is, the better. But the thing that the lesser it is, the more time your analysis will take. So I'll come over to this point and click on FE mesh and analysis. So I'll click on this. Then once I click on this, let's wait for this thing to load. Look at it. It's already designing reliable soil stress. So look at it, it's already designing. So this is what we're having now. Reliable soil stress 1.2 and shake will based on this what pressure. So this is what we're having. So let's wait for it. It's designing. Remember, you can still get the CAD file and practice on your own. And also, if you are finding this video helpful, you can share it in your class group if you're a student, or in your work group if you're a practicing engineer. So the say foundation beam effect is being updated. I'll just click on OK. Yes, so I'll click on OK. So look at it, analysis completed. So once it's analysis completed, I'll come over to this point, display analytical model. I'll then click on it. So let's wait for it to display the analytical model for us. Remember, you can share this video and also like it if you are finding it helpful. Yes, share it so that more people will get to see it, and also you can get the CAD file and practice on your own. So this is the analytical model. So look at what we mean by that shear element. So if you see now, look at that 1000, look at that 500 and 1000 that I'm showing you. Assuming I choose any value less than 1000 or less than 500, this triangle will be smaller. Yeah, this shear element, it will be smaller. What it also means is that the analysis will be more accurate. But I will just advise you to just leave it at default. So this is what we are having. If you want to check the animation, so you click on this to see the animation, but we don't need it right now. So what I'll do is that I'll come over to this point that says contours. I'll click on contours, then come over to this point and then click on contours. I'll click on this, then a dialog box will appear here. Let's wait for it to appear. I'll click on this. Let's wait for the narrow box to appear. So look at it, it has appeared. So right now, we will begin to load each and every, we will begin to load all this into our structure. We'll begin to load all of them in our structure. So let me have it. I want to have it like this. Okay, let me click on just top view. Yeah, the top view. Yeah, okay, and then I'll zoom. So if you can see, look at it, anywhere that is purple in color, that means the road coming to those area is very very small. Yes, if I'm having purple color, that means the road coming to is very small. If I'm having red, that means the road is increasing. Why? The point that is blue in color means that it is those points that have the highest load on acting on it. So that's why I included this cantilever slab. So if you see, it's all these edges that are blue in color, because the load coming to this part is very high. That means maybe it might be that after designing this it might fail, but I don't know. Let's just design. So look at this, look at it. We're having column here though, so here is blue. So it's because assuming I increased the cantilever slab, assuming I made it something like 1800, that means the load coming to it will be lesser. Yeah, because that cantilever slab will be able to distribute its load to the soil. So let's just continue with our analysis. Look at it, it's all these edges that are blue in color, meaning that the load coming to these edges are very high. Reason is just because this column do not distribute its load very well to the soil. If you look, all these center columns, look at them, they are just green. They are just green in color because their load we are distributed to the soil evenly. That those top slab around it helped in distributing its load to the soil. So right now, what I'll do now is to load this structure. So I'll come over to this point and just be clicking them one after the other. So I'll allow it to load. Yes, I'll also come and click on this and I'll still allow it to load. So look at it now. I will come and click on this and also allow them to load. So right now we are through with this. So next thing is to come and load the forces. Yes, I will allow it to load. And load this horse. I'll just be doing it one after the other and I will allow them to load. So I'll also click on this and allow it to load. I'll also click on this and allow it to load. I'll also click on this and I'll allow it to load. Yes, I will click on this too and also allow it to load. So look at it. So we are through with the forces. We'll come over to the bending moment. I'll click on bending moment in direction 1. I'll click on moment in direction 2. Yes, moment in direction 2. So this is what we are having, is still the same thing. Then I will now click on this moment in dimension 1 and 2. That's the torsional moment. So let's allow it to load. So this is what we're having now. I'll come over to the design moment. I'll just be loading it on this structure. I'll be clicking on it so it will load on this structure one after the other. So this is what I'll do throughout. I've clicked on this and also look at this. I will still allow it to load. Remember, we are still going to do the beam route detailing. We are still going to detail this in AutoCAD, so you can still check it. Yeah, you can still check our video where we did the detailing, so you see it. Yeah, after this now, the next thing is detailing. We'll enter into detailing. So where I forgot to explain something. This is the area of steel required. Yeah, this is the area of steel required. But normally, I always like to use this second area of steel, and I'll still explain something using this second area of steel. Yeah, so this is what we're having. This is also what we are having at this point. Yes, then coming over to the area of steel. Look at, I'll click on this. Look at what we're having here. So in this thing now, you can use your steel table and provide reinforcement using this. Yeah, you can use your steel table and provide reinforcement using this, or you can go with the one that the software gave you, any of them. So I'll also come over and load this. Yes, I'll click on this and load this. I'll also load this. Yes, and I will also load this. I will also load this. So the area of steel here is 170. So I will also come over to this soil pressure and also load this. So coming over to my soil pressure, I'm having it to be 72. So if you see where we are having this soil pressure is at this estimate. So this is why we inputted the cantilever slab to be able to spread this load. But if you see the pressure at this end, they are still much. That's why we are having 72. The pressures at this point, they are still much. They are still much. But look at the check that you must do. You must surely do this check. What is that check? Let me bring out my calculator. So if you can remember, the formula for ultimate load in Euro code, remember we are using Euro code. The formula for ultimate load in Euro code is 1.35 GK. GK means dead load plus 1.5 QK. QK means life load. Yes, that's the formula for Euro code. So in this case, we have, what is coming to this structure now, we are assuming is the dead load. So here we are going to do 1.35 times what is our soil bearing capacity. We use the soil bearing capacity of 70. Yes, so we are having it to be 94.5. Please make sure that this value that you are getting here is more than the value here. Yes, make sure it is more than the value here. Look at it. We're having 94.5, while here we're having 72.1. That means because the load coming to this, the highest load this structure will transmit to the soil is 72.1. Yeah, that's the highest load that this structure will transmit to the soil. And two, the highest load the soil can carry is this 94.5. It is gotten from 1.35 GK because we're using ELO code. That's why we use 1.35. But if you're using ELO code, you use 1.4. Yes. So the highest load the soil can carry is this 94.5. While the highest load this structure will transmit to the soil is this 72.1. So if you can see with this now, that means the soil will be able to carry the load coming from this structure perfectly. Yes, it will be able to carry the load coming from this structure perfectly. But assuming you do not input this cantilever, I promise you it will fail. Yes, because the load will not be distributed very well at this country at these edges. Yeah, that's why I say you must input the cantilever and to try and go with the minimum of 500. I hope I've explained this thing well. So if you want to see your solid model, yeah, let's wait for it to load. In case you want to see your solid model, let's wait for it to load. In case you want to see your solid model. So in case you want to see your solid model, so this is our solid model. What does this thing mean? Look at it. Blue means the highest load. That means this is the column carrying the highest load, and this is also the column carrying the highest load, and this is also the column carrying the highest load. And if you can remember during our interactive design, yes, it is this column is this column that we are referring that will increase to 300, that will increase from 225 to 225 by 300. Yes, that's why I now say that all this column inside I will be using 225 by 300 for all of them, because if you can see now, look at here, look at here. If you can see, is all this column inside that are from this point to this point, is all this column inside, because the load coming to them is high and the load coming to this external ones is small. That's why you'll be seeing them. They will be ranging from here downwards. Yeah, from this green downwards. That's why I say that all my inner columns I'll be using 225 by 300. While all my outer columns I'll be using 225 by 225. Yes, because the load coming to them are not really that heavy. If you want to learn more, or if you want to hear more of what I said based on this, you can go to where we did the analysis and design. So right now we'll be going over to the beam design. We are through with the foundation design. We'll be going over to the beam design. So I'll come over to my plan view. Yes, I'll come over to my plan view.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
So once I come over to this plan view, look at it. Our FE foundation analysis, it has been checked good, means it has been designed. So but right now I'm not seeing my reinforcement design, like the reinforcement that was being provided. So what I will do is that I'll right click. I'll first of all, yeah, I'll right click. Let's wait for it. I'll right click, then click on update steel bar. Let's wait for it. Let's wait for it. Yeah, it's loading. Look at it, it's loading. Don't worry, you still see it. What a hair. So look at it now. So this is what that was being provided for us. Hope you can see it. So look at what is being provided for us. T16 at 250, T16 at 250 at the top, and also T16 at 250 at the bottom. So if you see, all the provision they made here is what T16 at the top and T16 at the bottom. But you need to see something. But I'll explain more on this once it comes to detailing. So if you see this T16 at top, look at it, is the one running across this slab. Why this one that is we normally provide for moments in normal slab, yeah, in story building slab, in normal slab, look at it, it is now bottom. But this one that we used to place at the bottom in normal slab, they put it as top, and this one we used to provide as the moment, that's the top reinforcement in normal slab, they put it as bottom. Is correct, but I'll explain more on this when it comes to what detailing. Yes, when it comes to detailing, because you know before this, don't worry, I'll explain more on it when it comes to detailing. If you want to understand it more, make sure that you watch the video that we are going to do about this beam raft detailing. Yes, it is for free. Yeah, I'll make it for free, so it's for free. So if you can see this normal one, normally in our slab we used to call this B1 or B2. Why this one that is for continuous beam, we used to call it T1 or T2. But if you see, it has been changed. Okay, let's go over to story one. So you see what I'm explaining. Let's go over to story one. So I'll double click. So look at this is our story one. So look at, I are seeing it, this one that land across here, I'm having it as what B1 as B. Okay, let me check for another one. Okay, look at it here. Look at here. Look at this one that run across here. I'm having it as what B. And this one, once you come over to this one, I'm having it as what T1. But once it comes to foundation, it's different. It's correct, yeah. But once it comes to detailing, that's when I'll explain this very well for you to understand. So right now, let's go over to foundation. So right now we have done our we are through with our slab design. Next thing is to design our beam. So to design our beam, I'll come over to this tab named design. Then I'll come over to beam design. Look at it, foundation beam. So I'll click on this foundation beam. Look at it, it is marked bad because we have not yet designed it. So once we come to this place, I'll come to this beam design bash mode. So I'll click on it, then I'll click on reselect all bars, so it will design my beam for me. I'll then click on calculate. So let's wait for it as our beam is being designed. Don't forget, make sure you watch the beam detailing of this. It will be, the link will also be pasted in this video description when we do it. Yes, I'll paste the link there, so you get to learn a lot. You are going to learn a lot about beam detailing. Yeah, for example, what I just showed you now about top reinforcement and bottom reinforcement, when they change, what's the reason that they change? You get to learn it because I'll explain it there. So in this case, I'll click on close because it has been designed. So look at it, it is being marked good. We will still do our interactive design. So I'll close this, and then I'll come over to my display to turn on my visual, to turn on my design status. So I'll click on this. Let's wait for it to appear. So I want to turn on my design status, so we'll know the beams that are failing and the beams that are passing. So I'll click on this and then click on OK. Yeah, so if you can see, oh, we made a mistake. I forgot to run our slab strip across this cantilever slab. So if you see it, it is not designed. It is not designed. Yeah, but I know that if I should assume I designed it, I will still be having this T16 at 250. I'll still be having this T16 at 250. And to note, once it comes to detailing, I will not use T16 at 250. I'll use T16 at 200 because of what I have been explaining. Yeah, once it comes, I'm located in one of the African country, which is Nigeria. Once it comes to most of all these African countries, they tamper with quality. Yes, their T16 is not T16. Their T16 can be T13, T14, or T15, and thereabout. And the 460 yield strength that we use might be 430, 440, or thereabout. Yeah, because they are trying to make profits in their production. So for that reason, I'll try to counter that to prevent building collapse. So I did not do this design. So no, but normally, as we were to do the design, I'm sure that you can do it. Once it comes to slab strip, you go to finite element and then you use the boundary condition for cantilever. Yes. So but in this case now, I will just do the interactive design of few of these beams, not all of them. I'll just do for few. So to carry out my interactive design, I'll come over to this foundation beam. I'll click on it again. So if you see, as we have designed it before, all of them passed. So but I'll be checking them one after the other, but I'll not do all of them in this video. When you get the CAD file, you can practice on your own. Then at this stage, you now check all of them on your own. I'll just pick random beams. Yes, I'll just pick random ones. So I'll double click on this. Let's check on this. So this is what we're having now. So if you can see, this is what I'm having. This is what I'm having. 2y16, 2y16. I'm okay with it. But if you can see, they did not include web bar. Now let me include web bar and show you what web bar means. So in this case, I would like to include 2 web bars, and I would like it to be also 2y16. That's the web bar. So let me come to my detailed drawing and show you what the web bar is. So this is what is called web bar. This and this. If I see I included 2, that's what I'm having. 1, 2. Yes, the reason for this web bar is because of shear. You know, this is a very deep beam. It's a deep beam. So if I not include this web bar, this beam now might twist, and it will fail due to twisting. So to prevent that twisting, that is why we do include this web bar. Yeah, to prevent that twisting, we include web bar. So you must include web bar even though the software do not provide it for you. Once your beam depth is more than 600, you must have web bar to prevent that twisting from occurring. So I'll click on it. So you can see the software do not provide web bar. So we are going to check many of them to be sure that software provided web bar. And if they do not provide any web bar, we will include our web bar. So I'll come over to this point and click on OK. So I'll pick another 3 random beams and then stop. So I have this. Look at this one. I would like to click on this. Remember, I say I'll just pick it at random. So this is what I'm having right now. 2y16, and coming over to this support bar. Look at this. This is the support bar. I will decrease it. So I'll decrease it. I'll remove it. What I'll do, I'll come over to this point and I'll extend left to wrap. I'll extend left to wrap. Yes, this is what I'm having. And coming over to this point, and I'll also extend right to wrap. I'll extend right to wrap, extend right to wrap. So look at it. This is what I'm having, but it is still failing and it is still less than 100. So what I'll do is that I'll come over to this point and input one top bar. Yes, I would like to make it to be Y16. So this is what I'll be having now. Then I'll come and include my web bar. I'll come and include my web bar, which is 2Y16. Yes, 2Y16. I'll also come over to this point, include my web bar, 2Y16. Yes, this is what I'll be having. So let's go over to our detailed drawing. So let's shake. So in this case, this is what we'll be having here, and this is our sectioning. So at this case, I'll just come and click on close and then click on OK. So this is what we are going to do for all of them. Now I'll come and check on this one again. This might be my last one. So this is what I'm having. So I don't want this. I will then click on this one, extend right to wrap. I'll click on extend right to wrap, then click on this, extend left to wrap, extend left to wrap, extend left to wrap, then I'll leave it like this, then include my web bar. So 2Y16, that's what I'll be having. I'll increase it to 16. So this is it. I'll come over to this point to 2Y16. I'll also increase this 2Y16. So this is what I'll be having. So I'll come and click on OK. Then on your own, once you get the CAD file, you can do everything on your own. So I'll come and click on close. So right now we have successfully model and design this beam raft foundation. In our next video, it will be about detailing of this beam raft foundation. So you can also watch out for it because we are going to learn a lot from it. Remember, if you find this video helpful, please do well to like this video. Yes, don't just like, you can as well share it in your class group if you're a student, and also share it in your work group if you're practicing engineer, so that more people will get to see this video.